We take the example and we try to rewrite it for using the Cramer rule. Now the Cramer rule eliminations are at the point there we get the differential equation. When we get the differential equation, then we use our method for solving the differential equation. This is only for example, there we eliminated y and we get the equation for x. Here we do the same thing. Then we use the Cramer rule for finding equation of in x or in y. T is our independent variable. X is the function of t, y is the function of t. So that's the point there. We say we use here Cramer rule to write. To use the Cramer rule, we try to write this equation in the matrix form. Lx is equal to f. In this form, we shall write this equation in the form Lx. L is the coefficient matrix, x is the matrix of unknowns, and f is our right hand side. So we try to write in this form. So we write the operator form again. We can. I have the solution of this one. In the operator form, our operator form is dx minus 9y is equal to 1. We take the variable on the left hand side. Then I'm having here x plus dy is equal to 2. I read the matrix form. The matrix form is the coefficient matrix is d minus 9, 1 and d. And then I have here multiplied by the column matrix xy, and my matrix of unknown is my 1, 2 is the constants. So this is my L, this is my x, and this is my f. Now I use the Cramer rule. The Cramer rule is a x is equal to, this is determinant of a determinant of a1. So I have my a is d minus 9, 1 minus d, x is equal to, I replace the first column by the constant. My constants are 1, 2. So I replace by this one, and then I have the differential values 9 and d. So now I can just simplify this one. Simplify this one, I get here minus d squared plus 9 into x, differentiating here d by dt. When multiply one is mean we take derivative of this one, and plus 18. So we can get here, we can write this one. This is equal to d by dt is equal to 0. We get here 18, and we can write this equation as we are having here Lx equal to f. The L is the differential operator in the matrix form, and coefficient matrix, as we say. X is unknown, f is the matrix of the constant of the left and right hand side. So we use the Cramer rule. In Cramer rule, we are having our x is equal to, over here, our x is equal to determinant of matrix is equal to determinant of matrix A1 over matrix A. I just multiply the A, I get here A into x is equal to determinant matrix A. So A is a coefficient matrix, that's as we show as the L. So get here d minus 9, and then we are having here 1 plus d, this second row, A11, A11, A12, A21, A22, then x is our unknown, and get 1, 2, our replace in Cramer rule, we replace the first column by the right hand side 1, 2, and then we can get here multiply to get d square plus 9, and we are having here this is d square plus 9x is equal to d by dt. So here is d is our d by dt. D is our, we must forget it. This means when we say multiply 1 by d, that means we differentiate when 1 with respect to t. So derivative of this one will be equal to 0, and here we get minus sign, and we get here plus 18. So differential equation I am going to get here d square plus 9 x is equal to 18. This is my differential equation, and here non-homogeneous differential equation, as I mentioned before. I have solved it, and we get two parts, yc and yp. We are having here the characteristic equation for this one. We are having this d square plus 9 x is equal to 0. So we take x is equal to e to the power mt, and we get here m square plus 9 equal to 0. That gives me the roots of m are plus minus 3i, and as above I get the value of xc, because the solution will be xc plus xp. So will be xc is equal to c1 cosine 3t plus c2 sine 3t, and we have calculated the value of xp. xp was equal to 2. So we can write here the solution of that one as I wrote before, that my x is equal to xc plus xp, and then we are going to get here this is equal to c1 cosine 3t plus c2 sine 3t plus 2. Similarly, we substitute in equation 1 and we get the value of y. Value of y was equal to minus 1 by 3 c1 sine 3t plus 1 by 3 c2 cosine 3t, and when we get minus 1 upon 9. I will say this is my solution of the differential equation, solution of the system, solution of differential equation of dE. I write differential equation dE. This is my value of x and y. So my value of x is equal to c1 cosine 3t plus c2 sine 3t plus 2, and we having y equal to c minus c1 over 3 sine 3t and plus c2 over 3 cosine 3t minus 1 upon 9. So this gives me the solution of the differential equation. You can see the only thing which you are having here till this point that we get here differential equation by using the Cramer rule. Otherwise they are same, there is no difference between these two methods. Only the method is how we reach from two equation to one equation and then we solve that one. That we have a system of equation and we simplify this one, eliminate x, and we get eliminate y, we get equation x, or eliminate x. So to decide that which equation we have to take, we look on the equation. As I told you that we can separate solve for x and we can solve for y, but we having the arbitrary constants and then we have to get the relationship between that one. So we decide about looking on the equation. We have the complicated problems also. The equation that if we substitute x, can we get the value of y? If y, then we calculate for x. And if we look that if we substitute a value of y in one of the equations, then we get the value of x, then we go for that one. That we decide upon looking on the question carefully.